So today, I've had the pleasure of speaking with many of you about the incredible things that you're building with ArcGIS. And this morning, in the plenary session, we saw some of the current capabilities of ArcGIS. Sasha showed us integrating with big data platforms. Miles showed us the power of imagery. And he used the new Gaussian splat capabilities to take a peek through the window of the set of Bridgerton. I think he's still recovering from what he saw. Katie channeled her inner Doctor Who to take us on a journey through the time capabilities of ArcGIS. And I'm going to borrow her time machine just for a few minutes to look ahead and share with you what we're building at Esri and what you can expect with ArcGIS over 2026 and beyond. And at Esri, we continue to invest in research and development, advancing the science of geospatial, with projects in many different areas. You can see some up here: AI, 3D, BIM, digital twins. And we continue to release updates to ArcGIS with these new capabilities and a focus on security, performance, and quality. And these projects, they're not just driven by us, by our ideas, but by you, by your ideas. And I'd encourage all of you to visit the ArcGIS Ideas site. You can submit ideas for new features and product enhancements. It's your opportunity to influence the roadmap. And it really does drive our product managers. If we take ArcGIS Pro, for example, in the last 12 months, they've implemented 200 of your ideas, with more to come. So when can we expect to see some of these ideas? Let's take a look at the timeline. Now, before I look ahead, I hope you'll indulge me just for a minute to take a quick look back to March this year, which saw the final retirement of ArcGIS Desktop, which was first released with ArcMap nearly 27 years ago, which terrifyingly is the same year that I started work at Esri. And while some of us soldier on oblivious, ArcMap was really beginning to show its age with the technology and architecture on which it was built. And whilst I, and maybe some of you, will look back with a little nostalgia on something that was a big part of our GIS journey, it really is time to look forwards, and there's a lot to be looking forwards to. So sticking with the theme of desktop, by the time you get back to yours at the end of this week, we'll be releasing ArcGIS Pro 3.7, and that will be followed later in the year by Pro 3.8. Next week, we'll be releasing ArcGIS Enterprise 12.1, which is a long-term support release. And that will be followed at the end of the year by 12.2, which is a short-term support release with plenty of new beta features to look forward to. We're also planning 3 releases of ArcGIS Online this year, the next one in June, followed by another in October. And what can you expect to see in these releases? I've pulled out just a few of the highlights. So, starting with ArcGIS Online, we've got lots of new data types and layers. I'm particularly excited about GeoParquet layers. We'll be able to create and publish huge amounts of vector data with the performance and scalability that you get with vector tiles, and the flexibility of symbolization and querying that you get with feature services. We've also got new tools to make administration simpler and improved usability to help your users create more accessible, better performing maps. With ArcGIS Enterprise, we continue to develop our data integration capabilities with more support for Databricks, query layers in the map viewer. And we're bringing some of the capabilities you saw this morning from ArcGIS Online. Data pipelines and ArcGIS Velocity are both coming to ArcGIS Enterprise. Now, as a parent, I know I'm not supposed to have a favorite child. And as chief architect, I'm not really supposed to have a favorite product. But if I did, it would be ArcGIS Pro. This is where we really get to innovate with spatial analysis and spatial visualization. At the top here, you can see the new timeline pane, which allows you to work with data points in both space and time. And below that, the new simulation capabilities, supporting airborne plume modeling. In the field of GeoAI, we've got new tools for working with geospatial embeddings, supporting AI-driven site selection workflows, and plenty of new usability tools, the most exciting of which is the new ArcGIS Pro Assistant. This will be moving into public beta with the next release. Now, the Assistant is launched from the Help ribbon and opens up a natural language interface to ArcGIS Pro. And it supports not just helping you navigate the documentation or generate code, but also includes geospatial agents that understand GIS concepts and know how to use and can use the tools within ArcGIS Pro to carry out these tasks on your behalf. So let's take a quick look. So you can see the Assistant pane on the right-hand side with the text box where I can enter my prompt. So select the hospitals that have at least one fire station within a mile and filter them by trauma status. And you can see it's selected the features in blue on the map and given me an outline of the query that it's run so I can check its work. So let's try another prompt. Okay. Export the selected data. In this case, the Assistant has launched the geoprocessing tool, filled in the parameters, and as the human in the loop, I can update these and execute the tool manually if I want to. So that's just a quick glimpse of the ArcGIS Pro Assistant. And that's only one of many projects that we're working on in AI. So let's take a look at the road ahead for AI in ArcGIS. So we've got some enhancements planned for the Pro Assistant, support for more tools, linking those together in GIS workflows, including custom agents that understand your business processes. And we've got plenty more assistants. As Mark talked about this morning, we plan to roll out assistants in many of the ArcGIS applications, helping you be more productive in your day-to-day work. We've already released a number of these in ArcGIS Online in beta and preview status, which means they're fully supported and production ready. And with the next release of ArcGIS Online, we'll be moving many of these into general availability with full documentation and licensing. For those of you that also have ArcGIS Enterprise, you'll be seeing these in public beta with the 12.2 release, moving to general availability following on from that. So if assistants are all about making you more productive, MCP is about connecting ArcGIS to external AI platforms, things like Claude, Copilot, Watson, and we plan to roll out support for MCP across the platform over the next few months. You'll see this first with a beta program, private beta program that runs alongside ArcGIS Enterprise 12.1, which means those of you who sign up will be able to start prototyping, testing, and most importantly, providing feedback to us about the services before we move them to general availability with the 12.2 release. You'll also see these in beta with the October release of ArcGIS Online. So MCP is about connecting ArcGIS to external AI systems, but we're also working on supporting geospatial agents inside ArcGIS. You've already seen this today. The ArcGIS Pro Assistant uses geospatial agents to run the tools in ArcGIS Pro. This morning, Sasha showed you an agentic mapping application, Data Explorer, one of our instant apps. And like all of our instant apps, that's built with the ArcGIS Maps SDK for JavaScript, which already includes the AI components that you need to build your own custom geospatial mapping applications. Sorry, agentic mapping applications. And for those of us who are not developers, we plan to bring a low-code builder experience, enabling you to create and deploy custom geospatial agents inside ArcGIS. So the road ahead for AI in ArcGIS is incredibly exciting, with advances in GeoAI, new assistance, support for geospatial agents. And I hope you're as excited as I am about the roadmap for ArcGIS as a whole. And whilst we're looking forward, it's also useful to take a quick step back and look at the bigger picture. All of us in this room understand the power of location data. But as the number of sensors and the data sources for this data increase, and the capabilities of the tools that we have increase, so do some of the challenges around data ethics, privacy, and trust. Indoor GIS is a perfect example of this. We're able to track the precise location of assets and people tagged with advanced sensors, phones as we call them. And this supports really powerful use cases. Crowd safety at events, asset tracking in hospitals and campuses, footfall analysis, stations and airports. But what does it mean for privacy? So this is just the sort of challenge that our tech research team love to get their teeth into. Can we rethink some of these use cases using GIS approaches, GeoAI, oriented imagery, real-time GIS, with simpler, more scalable sensors and a privacy-first approach to data? To talk you through how they looked at this, I'd like to hand you over to Matthew. Thank you.
Thank you, Dom. So to start, I just want to go back again to the theme of this year's conference, integrating everything everywhere. This, I think, is deliberately open to interpretation, but one area where I'd apply it is to the process of data capture. So for me, integrating everything everywhere is about how we collect data. So much of it currently is still relatively static. We capture snapshots of the world, then analyze them later. But continuous sensing is becoming more common. Remote sensors can monitor their surroundings in real time, and that data can feed directly into our digital twins. And to elaborate a bit, I want to continue on from Dawn's theme and think about how we monitor ocean currents. So in the past, data capture was extremely periodic. HMS Challenger, or ships like it, would put out to sea literally for years and physically bring back measurements. But with advances in technology, that has changed quite a lot. So we've shifted to more of a continuous sensing approach, like the one employed by the Ocean OPS, which combines thousands of remote sensors like buoys, floats, and autonomous vehicles to build a much fuller picture of our oceans. Now, it sounds high-tech, and it is, but continuous sensing is no longer solely the remit of large research institutions. Technology like wireless communication and ever cheaper hardware and compute mean the ability to remotely and continuously monitor a space is more accessible than ever. And I'd argue that just as dynamic as our ocean currents and just as vital to the functioning of our planet are the movement of people and objects around space. Now, I appreciate that's a bit of a vague statement, movement of people and objects around space, so I'll give you a bit of an example. Think of construction sites. Its effective management is all about the safe and efficient movement of materials from one area to another and ensuring personnel are in the right place at the right time and not the wrong place at the wrong time. Now, increasingly, estate managers are coming to us with these types of challenges, wanting to better understand how people and objects move around their estates. And this is not just limited to the outdoor world, but indoor environments too. Airports, for example, are all about moving people around the world, but to do this, they need to manage the local movement of people from the entrance lobby through security and even duty-free, and finally to the gates and the aircraft. Now, systems already exist to locate people and objects, like Dom said. GPS works pretty well for locating people outdoors, and indoor positioning systems allow us to monitor the position of tracking devices indoors. But this does, of course, require tracking devices for everything you'd want to track, which, depending on the value or the number of the things you want to track, is not always feasible. Which led us to our most recent research project, where we wanted to push the boundaries a bit and build a prototype system that monitors how an indoor environment is being used without the need for GPS or tracking devices. As you can imagine, you may have filled in some of the blanks. Any system that includes passively monitoring where people are raises questions about privacy and ethics that should be taken seriously and considered at the very start of a project. Ironically, though, I'll actually be coming to this towards the end, because first I want to introduce you to the first of several props that I'll be using throughout this demo. So here I've got what looks probably from the back just like a tripod, but it does have a camera at the top of it, and attached to that camera is a Raspberry Pi. It's fairly non-specialist, but how do I kind of use all of this to monitor a space? Well, there's really two core questions here. How do we detect things with a camera? And how do we then put those detections onto a map? So if I take each question in turn, how do we detect objects with a camera? Because I've got a camera, I can capture images or video. Because that camera is connected to my Raspberry Pi, which is basically a small computer with a little bit of compute, I can use some of the latest advances in computer vision to detect what's in the image. So this camera I've configured to detect people. So if I switch over to my second laptop, I'm hoping it's going to detect me as the human being that I am. And also, I think it's got the sign language interpreter. So at this point, you might be thinking none of this is really that new. Object detection has existed in ArcGIS for years. What is new, though, is applying real-time object detection to build a system that allows us to monitor the movement of things on a map without the need for trackers. There we go. So there's the detection, everyone. I should have seen the lack of kind of blinding white light going over your faces. So at this point, you might be thinking none of this is really that new. Object detection has existed in ArcGIS for years. What is new, though, is applying real-time object detection, again, to build a system that allows us to monitor a broad range of things without the need for trackers. So I'm going to switch screen. Perfect. So how do we do this second part? How do we plot these detections on a map? So from the object detection, we get pixel coordinates. On their own, they don't tell us really anything about real-world location. They tell us where something's located in an image. So I need to transform my pixel coordinates into geographic coordinates. But to do this, if you're got any expertise in photogrammetry, you'll know this. But we need to know where the camera is located in the real world, and also some of its characteristics like field of view and sensor size. Once we've done that, I've got real-world locations that become points on a map, and then it all becomes a little bit more familiar to us as GIS experts. So to show you a little bit about what we can do with this, I'm going to use my prototype, a few more props, to do a bit of asset tracking. So oftentimes in large buildings like hospitals, supermarkets, train stations, and airports, it can be hard to keep track of assets. I'm based in our Edinburgh office, which is relatively small in comparison, but we too have issues keeping track of things, especially when it comes to umbrellas. It's pouring down with rain outside. I need to pop out and get some lunch, and the umbrellas are nowhere to be found. If you don't know what an umbrella is, there it is. So how can I use my system to fix this? You may have already seen, but I've got a very small camera next to the two big cameras at the back of the room. I've also got Richard in the corner there, who's going to play the role of my Edinburgh office colleague. He plays it very well because he is actually my Edinburgh office colleague. And I'm going to use my camera, a floor plan of this room, and a very high-tech, very custom, very specific umbrella detection app to make sure that Richard leaves his brolly where it's supposed to be. So if we could have the house lights up a bit so he doesn't trip over. And if there's anyone superstitious in the audience, I would divert your eyes for this. So there we go. So as Richard starts to move around the room, I'm hoping that my camera and Raspberry Pi at the back are going to detect that there's an umbrella and perform some real-time georeferencing. That means we can see, hopefully, where the umbrella is on a map. And I can also see the route he's taken, which doesn't appear to be working right now. Quick refresh. So what we should be seeing at the moment is an icon of an umbrella, followed by some nice water droplets. But at the moment, it just looks like Richard's walking around the room for no apparent reason. So he's going to speed up the demo a little bit. Now, this was supposed to be a light-hearted example, but the important point is that the system isn't just limited to detecting people, which makes it suitable to some far more serious use cases. So if we think about its potential use in hospital, it could help make sure wheelchairs and beds are left where they're most needed. For items like these, it may not always be feasible to attach a tracking device, but instead could be monitored and mapped using cameras that potentially, I'm thinking of CCTV cameras, are already in place. That being said, our system, as I showed earlier, with this camera, does also work with people. So how could I apply it to a conference center like we're in today? So earlier this morning, some of you may have seen that we had this system using these cameras running down in the tech zone, passively detecting people's locations over the course of the morning break. I'll share the results of this in a moment, but before I do, I want to talk about something I mentioned at the start. When we start working with people's locations, especially in real time, we aren't working with umbrellas anymore. We're clearly dealing with some very sensitive data. So when developing something like this, there's really a third core question that needs to be answered. How do we do this in a privacy-conscious way? So how did we do this? First of all, we were transparent about what we were doing. Signage was positioned at the entrances to the tech zone, advising you about what was happening. We also had a stand in the research zone showing you a live view of the detections happening in real time. Secondly, no image data is ever stored. This would be totally unnecessary for this system to operate. A frame is captured, processed, and immediately discarded. So there's no video archive, no image data, and other than the points on the map, nothing to review later. Thirdly, there's no personally identifiable data anywhere in the system. So we're detecting people, not tracking individuals. There's no attempt to establish identity or follow someone over time, just anonymous detections in space. The data points we're working with, or that I'm about to show you, will tell us only that somebody stood somewhere at a specific point in time. Now, the foundation to much of this is the edge device setup. So all of the object detection, all of the coordinate transformation is happening directly on the Raspberry Pi. When we're detecting small amounts of objects, we can run this Raspberry Pi about 1.5 frames a second. With a crowd, it's a little bit slower. But this all means that no images or video are stored, viewed, or processed elsewhere. So this reduces risk and helps keep the system lightweight. So now that we've considered privacy, let's see, hopefully, the space management tool in action. So we've seen it detect me. We almost saw it detect an umbrella. So let's see how it works with a whole room full of people. So you might typically visit the tech zone to get your technical questions answered, and while you were doing that, we wanted to understand which areas of the room were most popular. From a health and safety perspective, this helps us make sure the room never exceeds a safe capacity. And as we plan for next year's conference in the Excel, we can't necessarily use the QE2 data, unfortunately, but we can make sure that we're providing the right stands and also that the most popular stands have enough staff. So let's look at what we captured. So I've created a dashboard that's going to let me digest the data. So to orient you a little bit, I've got a floor plan of the tech zone and marked out the stands. So we've got the Esri UK shop on the west side, and the research zone and the ArcGIS developer stand on the east side. If I turn my heat map on, I can see at a high level the areas where people spent the most time. So we had lots of people clustered around this area between the shop and the apps and cartography stand. The good news, I think, is that people weren't just huddled around the catering station, so it proves you're not just here for the free food, I suppose. But how did this change over time? So if I press play here, we'll start to see. So at the start of the morning break, as people were leaving the opening plenary, there were a few people in the area, probably members of staff, but then we see a big increase in the number of people on the floor, with people heading to the stands and mingling in the middle of the room. Really, though, it just looks busy everywhere, which isn't all that helpful. I think we can be a bit more specific. So here I've implemented the same geofencing logic that was supposed to help Richard return his umbrella. And I've used it here to understand which of the entrances and which of the stands was most popular. So we can, so here we can see the graphs evolving over time as people kind of enter and exit the room and visit the stands. But the question I want to answer is, how many minutes did people spend at each stand? You might be wondering what kind of units we're working with here. It's called person minutes is the unit we've come up with. So what is the most popular stand based on the amount of time people spent there? And the numbers, I think, have just finished coming in. And the winner is, fortunately, the brand new apps and cartography stands. Combined, you all spent over 1,000 minutes during that 1 hour period, so about 17 hours collectively. Then in second was another new addition with the Esri UK shop and the lovely Dawn Wright having her book signing. And then third was my personal favorite, the ArcGIS developers stand. In total, though, during that hour, you spent almost 3 days at the different tech zone stands, which is amazing. So what I've built with this is this prototype is a system that provides some really fine-grained and continuous insight about how our conference operates, without the need for tracking devices, just a few regular cameras, a bit of compute, and 30 minutes to set them up. And with that, I want to step back from the demo and finish on a couple of broader points. I thought I'd finish by coming back to why I think this really is road ahead. I'm aware I've shown you some things today that aren't all that new. Object detection isn't new. Georeferencing images certainly isn't new. But bringing them together into a lightweight and accessible system that applies the continuous sensing approach, that is new. And I think in many ways, systems like this are the technical future of GIS. I'm not saying all data capture regimes should apply continuous sensing, but for some, timely and continuous insight like this would be invaluable. But just as importantly as that, I think, is systems like this a part of the ethical future of GIS. That's certainly how we see it at Esri. Over the last couple of decades, we've moved into a world where personal data is widely collected, somewhat facilitated by the technological advances I've used today. Personal data is often treated as currency. People don't always understand when it's being collected and rarely have full control over it. So the approach I've shown today isn't just something I've bolted on for a fancy proof of concept. It reflects how we at Esri think about technology more broadly. In the context of AI, for example, as Mark alluded to, we don't use your data to train models. You always retain ownership. We don't sell metadata or rely on opaque systems. Instead, principles like transparency, explainability, and trust are central to how we build technology, so that at the end of the day, you can build systems that you and your users can trust. And for me, then, the road ahead for ArcGIS is clear. It's this continuous sensing feeding real-time digital twins made possible by increasingly more accessible hardware and increasingly capable software, all grounded in a privacy-conscious design. And with that, I think I'm handing back to Hattie and Craig. Thank you very much.